Hello everyone and welcome again. And if you remember, we were discussing about this Minkowski space, the four-dimensional space, and that is what we have is in the previous class we discussed about spatial invariance under the Galilean transformation, and then why we need the Lorentz transformation, and that Lorentz transformation leads to a space demand a space that needs to be treated as space and time all together at the same footing, and that was given by first developed by the Minkowski, and that is known as the Minkowski space, in which we have the space and as well as x1, x2, x3 coordinates, and then the fourth coordinate is treated as the time coordinate on this axis. Here you can see, and on the one axis is the space coordinate is treated. So any point in this Minkowski space is known as the world point, which is going to have world point. Any point on this in space is going to have known as the world point, and the movement of that point, if we join the movement of that point, if this point goes from here to here and then goes from here and then it started from here and then here, so if I join these points, if I join these point into whatever this is coming from here, so this is known as the world line. For example, this one is the world line of a point which is moving with the passage of time. Okay, so this is the time scale. This is point. This event is at this particular time. This event is at this particular time. This event is at this particular time, and the space point corresponding to this is this space point corresponding to this is this. So this is how you define, and the line joining all the events in a Minkowski space is known as the world line. So when you say a world line, that means we are talking about in the Minkowski space some movement of something in the Minkowski space with joins the world points together. Okay, so a useful concept in Minkowski space is the velocity of light, is that you can see that here that in special relativity of a light cone, we plot CT versus one of the Euclidean coordinates. So if I plot CT as the fourth coordinate, and then the one of the coordinate x on this perpendicular to this, so what you see, the origin of this xct is here at 0 0. Okay, now if you move further, this is one OA. This line is some world line. This line is some world line, that is some point is moving on this some world point, some object is moving along this line. This is a world line, okay, with uniform velocity. Okay, so with uniform velocity u. So this is having a slope with CT axis. So slope not with the x axis, slope with the CT axis. So when you calculate the slope, because this is making an angle theta with the CT axis, when you calculate the slope, that is going to be dx, and that is going to be dx, and this is going to be c dt on this axis. Okay, so what I'm going to calculate is tan theta is p by b, that is my dx by c dt, because theta is along this line. Okay, so that is dx is u, but it's basically dx by dt is your u, and then you have c here. So the tan theta is u by c. Now if you consider that this point is this line, or this line is representing an electromagnetic wave, is like when you start a pulse at this origin, the pulse is moving everywhere. Okay, and then you have a world line. If you target one point, that's how this electromagnetic wave is moving along this direction, and then what you see is tan inverse is, because theta is you can say this is going to be u by c. What is theta here? Theta here is tan inverse u by c, but u in her case, because we are talking about the electromagnetic wave, u is going to be c. So when this u is going to be c, so this is tan inverse, this is c by c, is going to be 1, and then for that theta is going to be 45 degree. Okay, So that means this is important, because for the light wave, for the electromagnetic wave, the path of a light ray is represented by the straight line that is going to be OC, an angle of 45 degree to the coordinate axis. Whether you measure with respect to this time axis, or you measure with respect to this space axis. Okay, so this is the world line. This is very important, that the world line of a light ray is defined by the equation that is s square is c square t square minus x prime square x square x2 square and x3 square. That is, if you see that x square equal to c square t square minus this x1 square plus x2 square plus x3 square, is s square is going to be 0. So where s is the interval between the origin and the point x1, x2, x3 on the world line of the light ray. Okay, this is going to be the world line equation. But important thing is that this 45 degree is important, because when we talk about the light cone, then there's defined that how wide we are. If you see that when you define the light cone, if you remember, we talk about this past and the future, and this there is if you draw an axis, this is my x-axis and this is my time axis ct, then this line is representing a world line of the light ray. So that's why always this is going to be 45 degree. Okay, why? Because this u by c formulation is giving you that the world line of a light has to be at 45 degree. So now we define the space-time and the 4 vector, that if you consider the two events represented as x1, x2, x3 and x4 separated by some space and time. In case system, if I have case system, then delta x, that event at x1 point, event and second xi point. Okay, and then the time, because the time is also involved with this, so time at event 2, what is the time at event 1. Okay, then the quantity delta s square, which is called the interval between these two events. So in my Minkowski space, this is my x and this is my ct. Whatever the two events is taking place at so at this point, and once one event and the second event in my Minkowski space, the delta s square is the interval between these two events is represented as delta x square minus c square delta t square, which is the invariant under the Lorentz transformation. So in special relativity, everything is to be invariant under the Lorentz transformation. So this is invariant under Lorentz transformation also in all inertial frame in relative motion. This means that if I have delta s prime, that is in k prime in Minkowski space, then this is going to be delta x prime square in minus c square delta t prime square. So I'm not going to prove it, because this is evident, you have already done it. So from equation 1 and in differential form, this is, I can write this, that ds square. So ds square is this dx1 dx1 dx2 dx3, and this is c square ds square. And in terms of the coordinate system, what you could write, this is s1 to the event at x1 and the event at x2. Okay, x1 and x2. So this is x2 minus x1, y2 minus y1, z2 minus z1, and c t2 minus t1. Okay, so based on this event, that is s square, you say s square all delta s square. Okay, normally we use delta s square or dt square in different forms, differential form or coordinate form. So we define our light cone, that is whether the interval is happening is a space-like interval, time-like interval, or light-like interval. These are the three terms which is important. We normally define when we talk in terms of the light cone. So what I told you that that there is a useful concept and a special relativity of, that is the light cone. So now we are going to discuss what is the light cone. The first thing we know that the light going to have one line of the light ray that is going to have a 45-degree of angle. Okay, so and the second thing, this transformation is going to be Lorentz invariant. That is the delta S square is going to be invariant under the Lorentz transformation. The first thing is a space-like interval. If you see, is defined as when the condition is fulfilled as delta S square is greater than 0. Okay, so first thing, delta S square is greater than 0. So that is the delta square, the interval between the two events. So when any two events is happening in the Minkowski space, and then the delta square between the two events, that the one event, this is x and ct, one this event is going to have some x and t components, and the second event is going to have some x and t components. So what is the difference between these two events? That is going to give you the event interval, and if that is going to be greater than 0, that means, because delta square is defined as d square minus ct square, so if this quantity has to be greater than 0, that means this depends, everything depends upon t square. So for a space like interval, the time separation between the two events, that is the time at which it happens, say t1, and the time at which this happens, t2, the time separation between the two events is less than the time taken by the light in covering the distance between them. Okay, so that means the two events which is happening between these two time is the time difference between this is t2 minus t1 is less than if you have t2c minus t1c. That means if you if you if you splash light, if you have a light here, and then this light reaches here, okay, at this point, so whatever the time this light pulse takes to reach from this place to this place, that is going to have the time. And what this event is happening is taking even less time than the light is taking to travel from this t1 to t2. So then if this is happening, then this such kind of events are known as the space-like event. That is, the time separation between the two event is less than the time taken by the light covering the distance between them. That means whatever is happening greater than the velocity of light, because when the light is reaching from this point to this point is taking some time, and what you are observing is taking less time as compared to the light. That means that event is flowing with the velocity more than the velocity of light. That's why the time is less. Okay, so this such kind of event is known as the space-like interval. So consequently, these two events cannot be connected by any real physical process, because you know that you cannot, anything can move more than the speed of light, because if it is taking less time than the light, which then the light, then that is moving with your two events are happening more than the velocity of light, so that cannot be connected by this. Okay, so you can, that cannot be causally connected. So we can always find an inertial frame traveling with v, which is less than the velocity of light, such that the two events may take place at different space coordinate but at the same time, delta t equal to 0, so that delta s square equal to delta x square. So this we can understood after a later time, that this statement I'm going to make you clear when we talk about in terms of the x and ct. But for the time being, the space-like interval are those interval in which the time taken between the two event is less than the time taken by the light to travel that particular distance. That means that two events are happening with the velocity more than the velocity of light. Okay, so that therefore the two events for the space like has no causal cause and effect relationship, that the time of event may be like t1 equal to t2, and t1 greater than t2, and t1 is less than t2, depending on the observer frame. So the past, present, and the future present is t1 equal to t2, and future is like t1 is less than t2, and future past is t1 is greater than t2. So cannot be defined relative to these events. So we cannot establish a relation between the first event and the second event. So you cannot say that uh, this is happening because of this, or this is happening because of this. We cannot correlate these. There is no cause and effect relationship between these two events, because these two events happening more than the velocity of light. That will be clear, okay, when we talk about the light cone. And the second is the time like event. This is all real process where delta s square is less than t. So when the time like event, the time separation between the two event is more than the time taken by light by covering it. That means that these two events are happening with the velocity less than the velocity of light. So that is all the real process. Consequently, the two events can be connected by any real physical process. That means that when we can know about this future and past and present, we can connect the future, we can connect the past and present, future, we can connect using this cause and effect relationship, because this is happening because of with velocity less than the velocity of light. Unless and until we can set up the relation, we mostly can move with as incomparable to the velocity of light. We cannot have something to measure with the something which can move with the velocity more than the velocity of light. So we cannot set up a relationship between those two events. But in time like intervals, where the time separation between the two events is more than the time taken by the light to travel between these two events, so we can always find an inertial frame such that the two events may take place at the same point in the space but at different times. That is same point, that is delta x is equal to 0, and different time, this is delta t is not equal. So this will be also going to understand. So the two event has cause and effect relationship. The past, present and the future can be defined relative to these events, because now we can measure, now we have the freedom to move with the velocity more than the velocity with which these two events had happened. Okay. And the last one is the light like interval, which is basically when delta s is equal to 0. So that means this is the two events are separated by a light ray. That means that is equal to this is 0, means delta x square is equal to c square. So this c delta t square, that means everything is happening with uh, the velocity, the two events is happening with the velocity which is equal to the velocity of light. So that's why it's a light like event. Now we can talk about this if I plot this x and ct in Minkowski space. So you can see that if this is my world line, and on which I have these are my world points on this world line. Okay, so what is this representing? This representing is some event. These are the event which represents the different world points. So this is happening at the same point with the different time. So something is stationary and the time is moving. So like I'm sitting here and the time is moving. Okay, so this is represented by, in Minkowski space, a straight line. This is parallel to the time axis, because time is not stationary, time is moving, but I am stationary but the time is flowing. So this is representing a world line of an object which is at rest. In the same way, if I have some kind of thing, then this is naturally representing a world line of an object which is moving with a constant speed, because it started from here, and then this is moving, the slope is a straight line, this is a constant speed. Okay, so now you know that like this one is telling you that the time is flowing but something is stationary, and then we have a word line is like with the slope with this time scale. Then this is going to have some straight line, then going to have a constant speed which is moving in Minkowski space. Some events are happening with the constant speed, and that speed could be these events, all these events here and here, can be of space like, can be of time like, and can be of like depending upon if you measure the delta S square is greater than 0, less than 0, or equal to 0, then we can decide what is happening. So if I have one frame that is x ct, and this is another k prime frame which is x prime ct prime, then how we define certain point in this. So if we draw a parallel line, if I have this, and if I draw a line here as parallel to x axis, then these are all these events which going to happen here are having the same time on this line. These are happening at the same time, okay, but and all these are happening at the same space. All these are happening at the same space, okay. So these are all happening with the same time on the same space here, if you say space, but these are all happening at the same time, okay, same time. And this is happening, this is happening on the, these are all happening in the at same space, okay. So you see that how to see in xy. But if you draw a different frame with this like k and k prime frame, then how you supposed to measure these things? So that means you draw a line parallel to this axis, that will give you the same time. These are all same timeline. And if you draw a parallel to this t axis, these are all giving you same space, okay. This is at same space, this is at same space. So you see that one thing, if I suppose that uh, okay, so you suppose that this is one event is happened, okay. So this is my world line. If you see, this is my world line, which is with 45 degree. This is the light ray world line of light ray, which is at 45 degree. And this is some event represented by this E. So in this X and CT frame, it is happening at XE with this line, and happening at CTE at this line. But the same event in this x prime frame, that is x prime and ct prime. So what you see that you draw a line parallel to this axis x, and you draw a line parallel to this axis ct prime. Then this going to give you the x space coordinate of this, and you're going to give you the time coordinate of this particular event. So it may happen that one event that is going to have different space and same time, and in the different reference frame is going to have same space and different time. For example, if I calculate this, if I say this is my two event, okay. So if I see in this frame, this is my x, this is my say k frame. So these two event are happening at this different x. This is say this is one x, this is at different, and this is the time is different, okay. So but if I have a frame which is like this is x frame and ct frame, then you see that these two events earlier in my ct frame were occurring at two different space, okay. These are occurring at two different space in different times. These two events were occurring in different space in different time. But in this reference frame, what I have is, if I draw to get this, so these two events, the time is given by this parallel line to this axis. So you see that, and these two events are happening at the same time, okay. So earlier these two events were happening at different space and different time, but in CT prime frame these two events are happening at different space. These two space are different here, because this correspond to this frame, this point here and here, but the time is same. That is what I mean by saying that if you say that Okay, so we can always find an inertial frame traveling with v less than c such that the two events will take place at the different space coordinate but at the same time. Okay, same time but different space coordinate. So that's why this is what I mean to say, that is these two events, which earlier were in this space, these two events have different space and different time, but in the ct prime these two events are occurring at the same time. Okay, same time but the different space. In the same way, if I have a two event which is having a different space and different time, but I can choose a reference frame in which this is happening at. If I draw a line, this is what is happening. This is my uh, x giving this space. This is a space coordinate. So these two event having the same space coordinate. Okay, same space happening at same space, but it's going to have a different time. Okay, this is going to have this time, this is going to have this time. Okay, when I draw a line for this time, so this is going to have this time and this is going to have this time. So I can always choose a frame in which the two events occurring at the same time, different time, but at the same space. So uh, there is a catch for defining this space like event and time like event, because in a space like event you see that the interval between the two events is less than the time taken by the light to travel that distance. That is, that those two events were moving more than the velocity of light. And when this happen, what is going to what you're going to do that, because these two events are going to happen in space which is beyond the world line of the light ray. Okay, and then cannot any physical reference, you cannot connect those two events by any real process, because I don't have any means to decide about or connect with that past, present, and future, because we cannot move with more than the velocity of light. Okay, so but those events are happening with uh, the speed which is more than the velocity of light, so we cannot actually connect in our process. Okay, that's why those are not real process. They are beyond the reality. Okay, so I think in the next class I'll start from here. This concept will repeat from here, that space like time like intervals, and then we will move further to define uh, the four vector concept. Okay, so I thank you all for concentrating, because this is something you need to understand with concentration. Okay, thank you all. Thank you very much.